Hi, this is Alex from devstories.eu. Shapely, episode 4 of 8. You are routing a new subway line near a protected wetland. You need to know if the track cuts straight through the water or just skirts the edge. How does the computer actually figure that out mathematically? It uses a clever 3x3 matrix to answer the question. This brings us to spatial predicates and the dimensionally extended 9 intersection model, or DE-9IM. Spatial predicates are binary functions. They compare two geometries and return exactly one thing, true or false. They do not create new shapes. They do not calculate overlapping areas. They simply answer yes or no questions about topological relationships. Under the hood, Shapely evaluates these relationships using the DE-9IM. Every geometry has three parts: an interior, a boundary, and an exterior. The DE-9IM is a matrix that tests the intersections between these three parts of the first geometry against the three parts of the second geometry. 3 parts times 3 parts gives you 9 possible intersections. Depending on which of those intersections result in an empty set, a point, a line, or an area, Shapely determines the exact relationship. Let us apply this to the subway line and the wetland. The broadest predicate is intersects. If the track shares any point, line, or area with the wetland, intersects returns true. It is the baseline catch-all. If intersects is false, the two geometries are completely separate in space. But you often need more precision. You want to know if the subway line actively cuts through the wetland. For this, you use crosses. A line crosses a polygon if its interior intersects the polygon's interior, but the line also extends outside the polygon. The DE-9IM matrix checks that the intersection of their interiors is a line, and not the line's interior also intersects the polygon's exterior. If both are true, crosses returns true. What if the track runs exactly along the border of the wetland without entering the water? That is where touches comes in. Two geometries touch if they share at least one point, but their interiors do not intersect at all. Only their boundaries interact. If the track veers even 1 millimeter into the wetland's interior, touches becomes false. Now consider a subway station built completely inside the wetland. Here you check containment. People often mix up contains and within, but they are just inverse operations of each other. If the wetland contains the station, then the station is within the wetland. Geometrically, it means the station's interior and boundary are entirely enclosed by the wetland's interior. No part of the station intersects the wetland's exterior. You can write your code checking if the wetland contains the station or checking if the station is within the wetland. The result is exactly the same. Here's the key insight. You do not need to memorize the 9 intersection matrix to route your subway, but knowing it exists explains why these binary checks are so reliable. Every named spatial predicate is just a specific pattern of true and false flags in that underlying mathematical matrix. Thanks for hanging out. Hope you picked up something new.